Good morning, dear students, and welcome to Vista's V-Learning, an online educational platform. My name is Denzil, your physics tutor for class 11. Let's get started with today's session. Today, we discuss a concept that is based on law of cosines and law of sines. We shall derive these law of cosines and law of sines in a given example, in a given moment as well. This is a session 3 of the chapter Vectors. Earlier in the other two sessions, we discussed what is a vector, how to represent a vector, and how to conduct certain operations on vector such as addition, subtraction, and multiplication. In addition of two vectors, we learned that there are two different methods of addition. One is called a triangle law of addition and the other is called parallelogram law of addition. In the case of subtraction of two vectors, we found that the two vectors are not commutative unlike addition. And in case of multiplication of two vectors also happens in two different methods. One method is what is called as a dot product. The other name for a dot product is a scalar product. When case of the next method, which is a cross product, we only cut short to the formula. But today we will discuss a little more about cross product and then we can proceed in deriving the law of cosines and the law of sines. So let's get started with cross product and how to identify the cross product of two vectors. Again, in the previous session, we learned when cross product is conducted on two vectors, the resultant answer what you get is also a vector. Therefore, cross product of two vectors are also called vector product. So we will make note of an alternative name for this cross product, which is also called vector product. And the reason why we call it vector product is because when you multiply two vectors, the answer what you get is also a vector. So let's have a look at the two vectors. One is A vector and the other is B vector. These A vector represented in an analytical format, which is using set of base vectors. Now remember the base vectors for a two dimension I cap and j cap. But here I'm going to represent it with a three dimension also with the k cap. So first I have A1 I cap plus A2 j cap plus A3 k cap. To make it more fun, make it more elegant, let me use different colors on them to show you the difference between the constants as well as the unit vectors. So first the constants A1, A2 and A3. Then the unit vectors I cap, j cap and k cap. All the three are added or subtracted accordingly. So here I will add. Similarly, for a B vector, I represent it with B1, B2, B3 and then I cap, j cap and k cap are their unit vectors plus along the x-axis, y-axis, z-axis, unit vectors. Cross product of these two vectors means A vector cross B vector, which can be identified by using matrices. So I hope you remember matrices from your mathematics class. So in matrices, you might have learned how to represent a given matrix and also how to identify the determinant of a given matrix. Now, trying to change the color, we'll change this color to red, I cap, J cap, K cap, all right? And then we fit in our elements. Which are our elements? Under I cap, I have A1 and B1. So A1 and B1. Under J cap, I have A2 and B2. A2 and B2. And under K cap, I have A3 and B3. A3 and B3. A simple way to represent it in a matrix format. Now we need to find the determinant. The determinant of this given matrix will give you the answer A cross B. So how do you find the determinant? You take the first element I cap. Again, let me change that color. You might have learned it in your mathematics class. To find the determinant, you take the first element, eliminate the terms under those, which are these elements A1 and B1, you eliminate and write down the remaining elements, which are A2, A3, B2, B3. So I will do that, but first I will write my set of vectors, your unit vectors. And now we write the elements. Which are the elements? A2, A3, B2, B3. Similarly, under J, eliminate the set of elements under J, and remaining elements are A1, A3 and B1, B3. I hope this is easy. And finally, for K, elements you eliminate under this A1, A2, B1, B2. So find the determinant of this 2 cross 2 vector, where you cross multiply each other term and you subtract. So in that way you get the third vector. Notice when you multiply two vectors such as A vector and B vector by a cross product, the solution what you get is also in a vector format. Okay, a quick note about the formula that we used. The formula we used is A vector cross B vector is equals to magnitude of A vector, magnitude of B vector, sine theta, n cap. N cap is a unit vector. All right. So in this way, you find the cross product of two vectors. We will look at those examples for dot product, examples for cross product soon. All right. Don't you worry. I'll give you those examples in the very next class. But first, now let's get to our topic, which is to determine the law of cosines and the law of sines by answering this question. So go ahead, read the question with me. The question says, find the magnitude and direction of the resultant of two vectors A and B in terms of the magnitude and the angle between and theta angle between them. So you have two vectors A and B. Find the magnitude of the resultant vector. So far, we have found the magnitude and direction of a position vector, just one vector. But here we have a combination of two vectors, A vector and B vector, which gives rise to a third vector, a resultant vector. We have to find the magnitude of that resultant vector. So go ahead and try to construct this with me. So first, we need to show these vectors by a figure. Pick a color, orange. All right. I hope this line is visible. Is it visible? No, it's not visible. So let me pick another color. Then I hope this line at least must be visible. Okay. So one vector, let's call this A vector. Now, there's also another vector. Let's call this B vector. How do you find the resultant of this vector? Is by constructing a parallelogram. So those of you who have difficulty in identifying the resultant vector, you can follow my previous class. Visit us at www.v-learning. There under playlist, you see the previous bridge course. I've taught you the addition of two vectors by two different methods, one called a triangle method and the other called a parallelogram method. So here we apply a parallelogram method. First, construct the projection. Select ink. We construct the projection of A vector, and then also we construct the projection of B vector. And they both coincide at a point. The point where they coincide is where the resultant vector is constructed. Let's call this R vector. Let O be the origin. Let me use a different color there. Okay, go ahead, construct it with me. While I'm drawing, I want you to construct it with me so that it becomes a practice for you as well. So O is the origin of these two vectors, which is also the origin for this resultant vector. Let P represent OP, represent the vector A, and OQ represent the vector B. To identify the length of this vector, let's say OS. Okay, we will write OS. To identify the length of this vector, meaning the magnitude, we have to deal with little bit of construction. So bear with me, follow very close. This construction involves in drawing a perpendicular line from S to the base. Okay, draw a perpendicular line. Draw a perpendicular line to the base like so. Okay, so you have OP. So we will represent this letter, this intersection of 2 points, as N. Okay, I hope this part is visible, correct? Yes. Perpendicular. Okay, and one last construction is drawing a perpendicular line from P to OS. A perpendicular line drawn from P. Arey yaar. P to OS. Okay. The angle between vector A and vector B is already given. How much is that? Theta. Very good. So the angle between vector A and vector B is given. So let me use a different color there. Color. Which color do I choose? Okay. Angle between A to B is given as angle theta. Angle between A to R vector, I will represent it with alpha. Similarly, the angle between the projection of this B vector as well as the resultant vector, let's call this angle as beta. Okay. Now, there seems to be a lot of things that are filled in a small space, but if you'd have followed the construction from the previous, then along with the practice in a notebook, then it would be easy for you to construct this even blindfolded. Okay. Now, since we need to identify the length of OS, let's consider the triangle OSN or ONS, either one. Okay. So from triangle ONS, use Pythagoras theorem to this triangle and you find that OS square is equals to ON square plus SN square. ON square plus SN square. So we need to find the length of OS. But do we know what is ON? No, we do not know what is ON. We know only what is OP. The extra length PN we don't know. Not to worry, we can identify what is Pn. So let me write that here. Where On is equals to OP plus Pn. OP you know well is A. But what about this extra length Pn? I don't know, sir. Let's quit. No, let's not quit. Sometimes when you feel like quitting, you just have to push your way through. And only then you find success, isn't it? Now, A vector, the base vector to the B vector, the angle between the two is theta. Similarly, this base and the projection of B vector is the same angle theta. You see how we identify? Because they are alternate angles. So you have a base angle and this B vector whose angle between the two is theta. Similarly here, since this is a projection, this blue dotted line is a projection of B vector, Pn to the projection of B vector consists of an angle theta. Now, if that angle is theta and if this dotted line is projection of B vector, then what will be the length of Pn? Use trigonometry ratio. What trigonometry ratio can you use in this case? Since you have base and hypotenuse, the trigonometry ratio that you can use is cos of theta. Cos theta is equals to base by hypotenuse. Base is Pn, hypotenuse is B vector. So what will Pn be equals to? B cos theta. So what will Pn be equals to? B cos theta. OP is A, Pn is B cos theta. So On is equals to A plus B cos theta. Notice one more thing here is you have On square, not just On but On square. So On square will be equals to A plus B cos theta the whole square. Good. So now we have On square. Do we know what is Sn square? Arey yaar, one Sn is not given, but not to worry, we can identify Sn. Once again, Sn represents the opposite side of a triangle because the angle is located here. Since it represents the opposite side of a triangle, you also have the hypotenuse, which is b vector. Opposite by hypotenuse. What trigonometry ratio? Sine theta. So where do I write? Where do I write? I write it here. Sine theta equals to opposite is Sn, hypotenuse is b vector. So Sn will be equals to b sine theta. Since you have Sn square, it will be b square sine square theta. So let's make note of this in the next page, where OS square is equals to ON square is a plus b cos theta whole square, a plus b cos theta whole square. Next, Sn square, Sn is b sine theta, so Sn square will be b square sine square theta. Okay. Since you have a plus b cos theta whole square, you can solve this by expanding it by a form which is a plus b the whole square. What is a plus b the whole square? A square plus 2ab plus b square. So expand this in that format. So you get a square plus 2ab cos theta plus b square cos square theta, and the remaining term plus b square sine square theta. Now, from these two, the common term, the common factor is b square. Okay, so taking that common factor, OS square. So here's what I'm going to do. I'll anyways write this OS square as r vector square, magnitude of r vector square, because we're trying to find its length, right? So magnitude of r vector square, meaning the length of OS represents the magnitude of r vector, a square plus 2ab cos theta, b square is a common factor, cos square theta plus sine square theta, and cos square theta plus sine square theta is equals to 1. Therefore, 1. Okay. Y is by an identity. Okay. Cos square theta plus sine square theta by trigonometry identity, it is equals to 1. So eventually what you get is this r vector, magnitude of r vector, which is equals to a square, okay, plus 2ab cos theta plus b square. So this is how you square root. I didn't put the square root. Why should it be under square root? Because r square, now you have r by taking square root on both the sides, and this result, what you get, this result tells you how to find the magnitude of two given vectors for a given of a given resultant vector, when two given vectors are added, the resultant vector's magnitude can be found in such manner. Okay, so I hope this is clear as to how to find the magnitude. This particular formula, what you have here, is defined as the law of cosine. So this is what is called the law of, I hope that's visible, yeah, cosines. Remember, our objective was to derive law of cosines and law of sines. So now we have derived one of them, which is the law of cosines. So go ahead, make a quick note of this. Okay. All right. Now, next is to identify the law of sine, meaning direction. We have found the magnitude. Now we need to find the direction of this given r vector. How do we find the direction? For that, we have to look at the diagram. So I have to keep flipping back and forth, don't mind. But for you, since you already have mentioned in your notebook, when I go back to the diagram, have a glance at your notebook diagram, which is the same. All right. So now, one more thing is to make note of this point of intersection as M. Okay, we'll make note of that as M. Okay. Now, by considering the two triangles, I know the plenty of triangles. I'll specify which triangle exactly. OSN. Okay, one more time. OSN. That's one triangle. The second triangle, which is PSN. Do you see the two triangles? OSN, PSN. Both of these triangles have a common side. Can you identify which one is the common side? Let's try. Is it OS? No. Is it PS? No. Is it ON? No. Is it PN? No. Is it SN? Yes. SN is a common side for both the triangle OSN and PSN. Do we know how to find SN? Yes, we do. Look at it. SN is equals to B sine theta. So let's quickly make note of this. In triangle OSN, SN is equals to, okay, let's go back. SN is equals to, I cannot write B sine theta now. Why? Because in triangle OSN, the angle is alpha. Correct? It is not theta. The angle is alpha. Therefore, by using the same trigonometry identity, sine alpha in this case, okay, sine alpha. So let's write that down. I'll write it here. Sine alpha, which is equals to Sn divided by OS. And what do we know about OS is vector R. So sine alpha is equals to Sn by R. So you can write that Sn is equals to R sine alpha. Okay, Sn is equals to R sine alpha in the triangle OSN. Let's take the other triangle. Which is the other triangle? In triangle PSN, Sn is equals to Psn. Sn will be equals to, since you have the angle now which is theta, so sine theta equals to Sn by B, which is B sine theta. So Sn equals to, it is that B sine theta. Both are Sn, so both can be equated to each other. So you have R sine alpha equals to B sine theta. So R by sine theta is equals to B by sine alpha. Let's put this as equation number 1. So this is just equation number 1. There's more to this. Yeah, I'm so sorry, there is more. But as we proceed, it gets more and more fun, okay? So all you need to do is write it down with me. If you are not writing it down with me, then things would seem boring, all right? When you write, it becomes a practice and also easy to learn. Okay, so this is 1. Okay, make note of this. I'm going to just step out of the frame and then walk in. Don't worry. All right. Okay. Next, we take another pair of triangles. These other 2 pairs of triangles, I will point them out. Have a look at it. OPM, one triangle. OPM, as you see, is one triangle. PMS is another triangle. Okay, OPM and PMS. From these 2 triangles, which one has a common side? Try to identify from these 2 triangles which one has a common side. Did you identify? Is it OP? No. Is it OM? No. Is it MS? No. PS? No. PM? Yes. PM has a common side of these 2 triangles. So since it has that common side, we will make use of that. So we'll mention in the triangle OPM. Select blue. Okay. So if you've made note of this, I think I'll erase this, but I'll write this, only this equation. R by sine theta is equals to B by sine alpha. Okay, we put that as equation number 1. Now, in triangle OPM, what is PM equals to? Let's have a look. PM we don't have a value, but rather we have this right angle triangle with one of the sides which is OP as a vector. Angle is theta. Use trigonometry ratio. PM is the opposite side. OP is the hypotenuse. How can you identify hypotenuse and opposite? Here's the hint. Identify where the right angle triangle is. Wherever right angle is placed, the 2 other sides which are mutually perpendicular, one is the opposite, the other will be adjacent. So the third, meaning the third side, will always be the hypotenuse. This is how you can find the hypotenuse in any given right angle triangle. So OP is the hypotenuse, MP or PM is the opposite. So you use opposite by hypotenuse as a sign. Sine alpha equals to. So go ahead, write it down. Though I don't have space, I'll make note of it here. sine alpha is equals to, let me try to recollect, you have PM by OP. So sine alpha is equals to PM by OP is A. So PM is equals to A sine alpha. Good. So we've got PM equals to A sine alpha. Now again, from another triangle, which is the other triangle? PMS. In triangle PMS, PM will be equals to, let's have a look at it. PM will be equals to, this side is the hypotenuse. Again, why is that hypotenuse? Perpendicular here. Other two sides will be opposite and adjacent. Obviously, the third side will be hypotenuse. Hypotenuse is present. Opposite is what we want. Again, you use the same trigonometry ratio, sine. But what is the angle? Is it still alpha? It is no longer alpha. It is beta in this particular triangle. So let's make note of it. Sine beta, which is equals to, let's have a look at the sides, I don't remember, opposite PM. PM by PS. PS is B vector. So sine beta is equals to PM by B. So PM equals to B sine beta. Both of them are PM, so which means these two can be equated to each other. So you have A sine alpha equals to B sine beta, and by cross multiplying, by putting the sine beta sine alpha into denominator, you get A sine beta equals to B sine alpha. Equation 2. By comparing the two equation 1 and 2, have a look at it. By comparing 1 and 2, you have B sine alpha in the equation 1 and equation 2. So by transitive property, one of the properties in mathematics, if A is equals to B and B is equals to C, then A is equals to C. Therefore, by transitive property, that you have R by sine theta, which is equals to A by sine beta, which is equals to B by sine alpha. Highlight this, put it in a box. This, what you have here, is a derivation for a law of sines. Law of sines. Yeah. Okay. And there's how do you identify the direction? Find the value of theta when beta and alpha, which should be given, or any one of the expression is given, either beta or alpha is known. Okay. Now, is there any other method? Certainly there is. Okay, there is another method. Again, by taking the triangle OSN. From the triangle OSN, this big triangle what you see, alpha is the angle. Now the two sides are known to us, SN and ON, because we have already found it. You see, ON and SN, we already have. So make use of that in order to identify the angle alpha. How? By using the trigonometry ratio tan. Tan alpha, which is equals to opposite by hypotenuse. Opposite by adjacent. Okay, opposite is Sn, adjacent is On. Sn by On. Do you know what is Sn? Yes, you do, which is b sine theta divided by, then do you know what is On? Yes, we do, because we have found On as a plus b cos theta. So a plus b cos theta. So in this way, you can also identify the angle which is alpha. Okay, so the two different, one is by using law of sines, and the other you can use the trigonometry ratio tan alpha, which is equals to b sine theta by a plus b cos theta. Well, that was a good run, isn't it? So now we have found the magnitude and the direction of any resultant vector by the combination of two vectors. So I have a problem to discuss with you, which happens to be an example problem from your NCERT textbook. A good problem, but since we're running short of time, we will discuss this in the next session. So I'll see you all in the next session. Until then, everyone, take care and do visit us at www.we-learning.in. So I'll see you all. Bye bye.